Still under limit. Still under limit. Example 5. Question says evaluate the following. Question 1. Limit as h tends to 0, x plus h all square minus x square over h. Why yours? You'll be solving limit as h tends to 0, x plus h all cube minus x cube over h. Solution. Let's just go straight to our question. Question 1 says limit as h tends to 0, x plus h all square minus x square over h. You know the first method is what? Always trying direct method. Abi? That's everyone's first choice. So let's try it. That will be x plus 0 all square minus x square over h is what? 0. So that will be giving us x square minus x square over 0. That will give us 0 over 0, which is what? Undefined. Which is undefined. So what does it mean? It means the question can go like this. It means we can solve the limit question using the direct approach. What can we do? Can you use factorization for this? Can you say divide 2 by d? Does it look like it? Can you say you want to rationalize? No. So another method is what? Which is the fifth method, I think. I think that's the fifth method, right? So another method we can use is the what? Expansion method. What do? Expand. Very, very simple. So let's expand. So we'll be having limit as h tends to 0. So let's open this guy. This will be x plus h in two places, x plus h. Then minus x squared, right? Over h. So we still write your limit as h tends to 0. So x times x will give us what? X squared. X times h will give us what? Plus hx, right? Or you can say plus xh, anyone. H times x will give us what? Plus hx. H times h will give us what? Plus h squared. Then what do we have? Minus x squared at the back over h. So what happened? This minus x squared, we cancel this, right? This cancel this. So what are we left with? Limit as h tends to 0. So what do we have? We have hx plus hx will give us what? 2hx. Then plus h squared over h. Now, what do you do in this place? If you still insert 0, your denominator will still be giving you 0, right? And you still have 0 over 0. So what do? We can factorize here. What do? We can factorize. So when we factorize, what are you going to have? You'll be having what? We can factorize what out here? H. So we can say limit as h tends to 0. Now be h into bracket. What do we have? 2x plus h, abi, over h. You know, when you factorize h in this numerator, when you factorize h outside, h into hx, what will remain? 2x. H in h square, what will remain? H. Then over h. So we can now say this cancel this. So what are we left with? We are left with what? Limit as h tends to 0. So what are we left with? 2x plus h. Now we can now insert direct as h tends to 0. What do we now have? That will be 2x plus 0. What's the final answer? Which is what? 2x. Which is 2x. Can you understand? So that's how we get this. That's how we get this. So you are trying for number 2. You are trying for number 2. And how do you solve number 2? It's very, very simple. It's still the same expansion method, right? So, but what do? You expand it in 3 places because yours is having 3. And if you're finding it difficult, you can use Pascal triangle, right? To open it in 3 places. You can use Pascal triangle, very short and simple. So, but if you don't understand Pascal triangle, expand it the way you understand. Shall you get? Thank you.